All right, so this lesson is so fun that it gets 2 videos. Very exciting. All right, so we have angle 7 that we ended with here saying it was 105 because 75 plus 105 gives us that straight line of 180. So now we can do a couple different things. We could say angle 7 and angle 5 are vertical. So that would mean angle 5 is also 105 degrees. We could then say angle 7 and 4 are corresponding. They share that same position, which would make angle 4 105 degrees as well. And we could say angle 4 and angle 1 are vertical, which makes angle 1 105 degrees. And you could also do that multiple different ways. Like we could have said angle 7 and angle 1 are alternate exterior. We could have angle 5 and angle 4 alternate interior. So there's a lot of different ways that you can use to figure out what the measurements of those angles are. Okay, so try to do the same thing here with number 14. Again, if you want to pause the video and try on your own, you could do that and then play it again to make sure that you're correct. You could also, not pause it if you want to do one more together here. So 125 here, I'm going to start and say, okay, that is vertical to angle 6. So angle 6 is 125 degrees. And then I'm going to say 125 and angle 3 are alternate interior. So this is 125 degrees. And then I'm going to say 3 and 1 are also vertical. So this is 125 degrees. Again, you could have done that other ways as well. So now I'm going to say, okay, I know that the 125 and angle 7 form this straight line again. So if I do 180 degrees, which is a straight line, minus the 125, that would give me 55 degrees. Okay, and so I know angle 7 and angle 5 are vertical. So angle 5 is 55 degrees. Angle 7 and angle 4 are corresponding. So angle 4 is 55 degrees. Angle 4 and angle 2 are vertical. So angle 2 is 55 degrees. And again, you could have used different reasoning there with all of those different types of angles. Okay. So the next part here that we're going to look at, we're going to kind of move away from angles and start looking at triangles. Okay, so again, more fun, exciting definitions and classification. So the first thing it says the sum of the angles in any triangle is, give you a second to fill that in. Hopefully you know it is 180 degrees. Okay, and triangles can be classified by their angles. They can also be classified by their side lengths. So first thing we're going to do is classify them by their angles. Okay, so an acute triangle has 3 acute angles. Okay, so a picture of that, I would have all 3 of these angles here, right? They would all be acute angles. Okay, a right triangle has 1 right angle. Okay, so our picture here, we would have to have the right angle marking, so that would be a right triangle. An obtuse triangle has 1 obtuse angle. Okay, so, something like this. So remember, an obtuse angle is an angle larger than 90 degrees. And an equal angular triangle is all angles are equal or congruent. Okay, so if I have an equal angular triangle, all of my angles here would be congruent. So actually, sorry, my acute triangle, you don't need markings on. This could still be an acute triangle, but I'm not going to put markings on there. When they have these markings, that means that they're congruent. Okay, so we could still put those markings on here. This would still be acute, but I'm just going to keep them only on this one so that like if they have these markings, it means all of the angles are the same measurement, which means it would be equal angular. Okay, we can also classify triangles by their side lengths. So we can have a scalene triangle, which has no equal sides. Okay, so this would just be a triangle, and there would be no markings on the sides at all. So that means that we don't know anything about the side lengths. Okay, isosceles has two equal sides. Okay, so that would mean I would have these two tick marks, so I know that these two sides are equal. Okay, in an equilateral triangle, all three sides are equal or congruent. Okay, so again, in my picture here, I would have a marking on all three sides, so I know that all three sides are congruent. All right, so there's also some special cases with the classification. So this is a triangle is equilateral, so the sides are going to be the same if and only if it's an equal angular triangle. So that basically means if you have an equal angular triangle, so I know that all these angles are the same, I then know that all the side measures are also the same. Okay, so if I have an equal angular, it's also going to be equilateral. Okay, and then an equilateral triangle is a special case where it's also an isosceles triangle, because an isosceles has two sides equal, and an equilateral has all three sides that are congruent. So if it's equilateral, you can also classify it as isosceles. Okay, so actually I'm going to add in our definition here. Isosceles, we're going to say is at least two equal sides. Okay, so if it has two equal sides, it's isosceles. Equilateral has three equal sides, so it could also be isosceles because it has at least two equal sides. Okay, so that makes our definition a little bit more clear. And again, you want to be looking for these markings. So those tick marks means that the sides are equal. And again, these angle markings means that the angles are equal. So number one, classify the triangle by its angle. Okay, so here we had this right angle. So this is a right triangle. Okay, in this one, we have this obtuse angle. So we know it's an obtuse triangle. Okay, and here we can tell all of our angles are less than 90 degrees. So this would be an acute triangle. So basically, every triangle always has two acute angles, okay? And you're really classifying it by its third angle. So it always has two acute angles, and then you're classifying it by the third. And this one, in this case, right, all three are acute, which makes it an acute triangle. So we're also going to classify by side length, okay? So same, picture here as the top. There's no markings on the side, so this is going to have to be scalene, okay, because we don't have any markings to tell us anything different. You can't say, this side looks like it's the same as this side. It has to have those markings so that you know it's the same. For number 5, you have the tick marks on all three sides, so we know that this is going to be an equilateral. Okay, and then for number 6, we have the markings on the two sides, so we know that this is isosceles. Okay, and actually equilateral, we're also going to say could be isosceles as well, okay, because it has at least two congruent sides. All right, so sometimes people get confused by, like it will say classify by angles, and they'll classify, scalene, equilateral. Okay, so if it says angle, make sure you're doing right, obtuse, acute. If it says side length, that's your scalene, equilateral, and isosceles. All right, so the last part here is if you're looking for an unknown angle measurement. Okay, so we already said that angles or triangles sum to 180 degrees. So in this first one, if I'm looking for this unknown angle measurement, I'm just going to add up what I have. So 60 and 43 gives me 103, and I know it needs to sum to 180. So I know that my missing angle measurement is going to be 77 degrees. Okay, so then classify it by its angle measures. So all three of these would be acute. So it's going to be an acute triangle. Okay, for number 8, same thing. I'm going to add up the angles that I have, and I know it should sum to be 180, so I'm going to subtract it. So I know that my third angle there is going to be 110 degrees, which makes this an obtuse triangle. Okay. All right. And number 9, find the unknown side length of the triangle given the perimeter. So here, I know that these are equal. So I'm going to say this is x and this is also x because they're the same. So I'm going to say 2x, because I have x plus 18 is got to be equal to the perimeter of 48. So now I'm just going to go through and solve this. And I know that my missing sides here are going to be 15 inches. Okay, because I knew that that was an isosceles triangle. And the last one, find the missing value of x and the angle measurements. Okay, then classify by angles. So again, I know that all of these should sum to 180. Okay, so I have 5x plus 20 is equal to 180. And then I'm just going to solve this. So here, this gives me what x is equal to. So x is equal to 32 degrees. Okay. So it wants the value of x, which we found, and the missing angle measurements. So I'm going to plug 32 degrees back in. So 2 times 32 degrees gives me this angle measurement of 64 degrees. 3 times 32 degrees gives me this angle measurement of 96 degrees. And then I would always just double check that. Okay, make sure that your math adds up. So I would do 96 plus 64 plus 20 and make sure that sums to 180. And it does. So this should be correct. So it also says classify the triangle by its angles. Okay, so we have 96, 64, and 20. So because we have an angle larger than 90, this would be classified as an obtuse triangle. Okay, so that is it for triangles and angle classifications. So there's a lot of information in there. So I would recommend kind of going back and going through this and seeing if there's anything that you're not sure on, maybe starring that. And then when we go through the notes together, you can ask about it. Okay, because again, there's a lot of definitions and a lot of notation and a lot of information here. Okay, so make sure that you have all these notes complete. Again, make sure that you write down or star any questions so that you can ask them during our live class session. And I will talk to you guys soon. Bye.